Hello, I'm Vedant, and today we will be discussing AtCoder Beginner Contest 450. So let's start with the first question. The first question is 3, 2, 1, go. So you are given a positive integer n, and we need to output the sequence in descending order separated by commas. So, for example, like this is a very direct question, I would say. Like, let's say we have n equals to 9, right? So basically all we have to print is 9, comma 8, comma 7, comma 6. Yeah, that's all we need to do in the first question. So this is pretty direct. So let's directly jump to the code. So all we do is we do a for loop from I to 1 and print them with commas, and finally we print 1, and that's all for the first question. So yeah, let's go to the second question. The second question is split ticketing. So there are n stations from 1 to n arranged in a straight line from west to east in this order. The AtCoder railway train passes through the n stations and runs from west to east. For any two integers I and j, the cost of boarding the train at station I and getting off at station j is Cij. And we need to determine whether three integers exist such that they are in increasing order and the total cost of boarding from station 1 and getting off to station 2, then from station to the third station is less than the net cost from the first to the third station, right? So yeah, basically, let's say this is a station 1 A, this is station B, and this is, let's say, station C. Let's say this is CAB, this is CBC, and this entire quantity is CAC, right? So here we need to find three such integers A, B, and C such that CAC is greater than CAB plus CBC, right? And we have n points and we are given all such values, right? So since n is only up to 100, what we can do? Like n is 100. And if we choose three integers from it, what will it be? 100 C3, right? Or if I say NC3, that is basically O of n cube, right? And since n is only 100, so it is basically of 100 cube, that is O of 1 is 6 only, right? So it will easily work. So what we'll do is we'll choose 3 points A, B, C, and like we'll choose all the possible points and just try whether it is possible or not. And if it is possible for even one of the pair, then that is our answer, and else it is no. Like this is just a direct brute force question, right? So as we can see here, the pairs are A, 1, 2, and 3, and we just calculated the values here. And it comes out to be 90 and 450. So 90 is less than 450, so it satisfies the condition. In the second one, similarly, no pair is found. So let's just check the code for the brute force. So first of all, we take the inputs, and then what we do is our three points are ABC that are basically I, J, and K. I goes from 0 to n. So J goes from I plus 1 to n. Similarly, K goes from J plus 1 to n. Now, if this partial distance sum is less than the total distance sum, then our answer is yes, else our answer is no. So again, this was a very direct question, just like the first question. So yeah, let's move on to the third question. The third question is puddles. There is a grid of H row and W columns. The cell at the ith row from the top and the jth column from the left is painted black if Sij is hash and white if it is a dot. Among the four directionally connected regions consisting of white cells, find the number of those that are surrounded by black cells. And below is a formal statement. We denote a cell at the ith row and the jth column. ith row from the top and jth from the left as ij, and two cells are said to be adjacent if their net distance and coordinate is basically one, the Manhattan distance, right? And yeah, so it is basically four directionally connected region, right? Like suppose if this is our cell, right? So we have these four as the directly connected regions, right? Or if we write it in the form of I and j, then for I comma j it is I plus minus 1 comma j and I comma j plus minus 1, right? These are the 4 points. And a set of C white cells is said to be connected if and only if there are two cells C and C dash, and it is possible to move repeatedly by moving to the adjacent cell. A non-empty connected set of white cell that is maximal is called a connected component of white cell. Find the number of connected components of white cells that do not contain any cell at the outermost border. So basically, all you have to do is we need to find the number of connected white cells and like the number of independent connected segments of white cells, you can say, and they do not have any cell on the border. So let's take the examples. So in this example, we can see that this this region of 5 cells is connected, but it has a border. It has a cell on border, so this we cannot include. Now this is one cell. Similarly, this is the second cell, these values and one value at the bottom. And now again, this is at the bottom, so this is not included. So the answer for this one is 2. Similarly, for the second test case, our first connected cell is these 3 cells and one cell at the top. This is our first one. And now these connected cells and one cell at the top is our second one. Now these connected cells and one cell here and this is our third one, right? Right. Yeah, this goes even down as well. These two cells are also part of this only, and this last line is also part of the second region only, right? And now these two cells here is the third region. The two cells at the left corner are not included because these are the border cells, right? And I think we missed some cells, right? Actually, let's just copy it and try to do it there. Okay, I'm not sure how. Yeah, so actually, I don't think the spacing is correct here. So can you take a photo and do it? Yeah, all right. So this is our, actually let me reduce the thickness, right? So this is our first one, right? And this is our second cell. Now this here is our third cell, right? And this is our fourth. So this is one, this is two, this is three, and this one is fourth, right? This is not included. Similarly, this one is also not included because both of them has a border, right? So these are our 4 cells. I guess we merged some of the cells there at counting. But yeah, so what exactly do we need to do, right? Like, can we just do this? Like, first of all, find all connected components, and then answer is equal to total minus number of borders components, right? And how will we differentiate the components? Like finding the number of connected components is pretty easy, right? All we need to do is we can just do a DFS or BFS call on all the cells, and we can maintain a visited array, right? And whenever the visited, like we can keep doing the loop for all the values, and each value will only be picked up once. And we can create a counter, and the counter will increase for number of times the DFS or BFS is called. So that count is basically the total, right? And then in the visited array, instead of just storing 0 and 1, right? In the visited array, instead of storing 0 and 1, what we can do is 0 is unvisited, and we can store some I, and this is the component number, right? Or you can say a C. And after each loop, we will keep increasing C as well, right? And finally, like value of C is basically what? Like final value of C is total only, right? And now C will differentiate all the components for us, and then we can just find the number of distinct values we have at the border. So our answer is basically C minus number of distinct colors at border, right? So let's test it with the test case ones just for clarity, right? So here when we'll do the loop, all these values will be rejected, right? The top column because none of them is right cell. So initially, let's say our C is what? 0, right? So now we will get this cell, right? And this will have the color value of 0. And then we will get this cell. So we'll get this component as 1. Fine. After this, we will get this component, right? And this is basically what? 2, right? Actually, it is better to draw this right. Then this will be our 3. This is 4. And this last portion is our 5, right? And now C's final value is basically 6, right? And our border values are what? 3 is at the border and 5 is at the border here, right? 3 and 5. So number of distinct values at border is what? 2, right? So our answer is 6 minus 2, and that is 4, right? We can do it like this, right? First find all the components and then just subtract the number of components that comes at the border, right? So this is basically C. So let's check the code now. So what we are doing is we are taking the input this grid. We are setting the initial color as 1 because we are treating 0 as unvisited, right? And now we are doing a loop, and if the value of the cell is white and this cell is not visited yet, so we do a DFS call. And finally, after all colors are done, we do a C minus minus because this last color is unused, right? And in the DFS, what we do? We do since four cells are connected to each of the cell, we do four DFS calls for x plus minus 1 and y plus minus 1. And if x is minus 1 or y is minus 1 or x is equal to the grids, like the grid endpoints. So what are these four values? These four values basically means that our current cell is out of the grid, right? So we skip these values. Similarly, if our current cell is visited or our current cell is black, then also we skip the value. Else we make this cell as visited and give it the current color. And finally, we do a loop on the borders. And if the border value is actually like if the border value is visited, that is if the border value is not black, it is white, right? So we take its color and store it in a set. So our final answer is the value of C minus number of distinct values in the set, right? So this is the code for C. And I hope C is clear. So let's move on to the next question. The next question is minimize range. So you are given a sequence of n positive integers and a positive integer k. You can perform the following operation on sequence A any number of times. That is, choose an integer and add k to it. Right. And we need to find the minimum possible value of max of A minus min of A. Right. So we need to find max of A minus min of A. Right. And we need to minimize this. Right. And what is our operation? We can change AI to AI plus K. Right. Actually, this question is very similar to a different question that came just a few days ago. So I'll show you that question first. It came in code chef starter 2 to 6. Right. And I believe it was problem C or D of division 2. Yeah, it was problem number C. So if you will notice in this question also we are given an array of n integers and we can perform the operation any number of times, and in this we need to multiply ai by 2, right? And we need to find the minimum value of these two values, right? So actually I discussed this question in the PCD of CodeChef, right, in the PCD of CodeChef starter 2 to 6. And actually this question also has the exact same solution. Both of these questions are actually the same even though the operation is different. So you can refer to this question as well before solving it because the answer is pretty much the same. So I'll discuss this question here as well, but you can try this question as well. These are the two same questions, right? So basically, first of all, what we can do is we can sort the array. And why will we sort the array? Because we are only interested in the maximum minus minimum. So actually, the order of values does not matter, right? And now what we can do is, since we need to reduce this value, we'll basically increase the value of the minimum element, right? So increase AI until AI plus K is greater than A max, right? So basically, let's say our current value of AI is 3, K is let's say 6, and A max is let's say 22, right? So we'll increase this value to 9, then we'll increase it to 15, and then it is 24. So we won't increase it to 24, we'll stop at 15, right? And how can we do this in a single operation? That is basically A new is basically what? Or what exactly we are doing? A new is what? AI plus some x times k, and this is less than equal to A max, right? And we need to find this maximum value of x, right? So basically x is nothing but less than equal to A max minus AI upon k, right? So we can directly change AI to k times A max minus AI upon k, right? And let's try this on this only, right? So we get k is what? K is 6 times A max is 22 minus 3 is 18 upon 6. So we basically get AI as 18, right? Okay, something went wrong here. 22 minus 3 is not 18. 22 minus 3 is what? It is 19, right? So it is 22 minus 3 upon 6. 3 plus 6 is 9, 9 plus 6 is 15, 15 plus 6 is 21, and 21 plus 6 is 27. So we will stop at 21 and not 15. Right. So yeah, let's try this now. And now, yeah, this is the value of x. So AI is basically AI plus this, right? And AI is 3. So this is what? This is 19 by 6, and this is equal to 3. So basically, AI is 3 plus 6 into 3, that is 21. So we can find the value for all these in O of 1. So we first sort the array, then we increase the value, and after this we'll sort the array again, right? Because it is possible that some value, because after adding k, we don't really know whether the array is sorted or not, right? There is no guarantee the array is still sorted, right? So now again the array is sorted. So now we have some values like a1, a2, a1, a2, a3, a4, a5, and so on, right? Let's let's just take 7 values for now, right? Or 8 values. So for this array, what will be the answer? Answer will be 8 minus a1, right? Because 8 is the maximum value and a1 is the minimum value, right? Now let's say we add a k to this minimum value. So a1 will change to a1 plus k. And now basically this is the new max. And now a2 is basically the new min, right? So this time the answer is a1 minus a2, right? And what about the next one? Now let's say we increase a2 similarly. So now a2 is changed to a2 plus k. So this is the max, and now a3 is min. So now our answer is what? A2 minus a3, right? So basically we can do this n times, and when AI is changed to AI plus k, so our max is AI and our min is AI plus 1, right? And for this our answer is AI minus AI plus 1, right? So after we have done this n times, right? So basically what happens? Our values were A1, A2, A3 up to what? A8. So our values will be changed to now A1 plus K, A2 plus K, and similarly up to 8 plus K. So isn't this basically the same condition? Because if we do max minus min, K will be removed. Like, or basically K will cancel out. So the process will repeat itself, right? So can we say that our answer is minimum of all answers calculated in n steps, right? And this is basically our answer. And in the code chef question also we have done the similar thing only. So I'll show you the code for this question now. Right. Let's take this example first. So our values are 4, 5, 10, 100 and 450 because we are sorting them, right? So our values are 4, 5, 10, 100 and 450, right? So 450 minus 4 is what? 450 minus 4 is 446. Actually, what is our k? Our k is 6, right? So 450 minus 4 is 446. So it is 4 plus 6 into 446 by 6, right? Actually, let's do this quickly. So I'll just calculate these values and add them by calculator, right? So we have 450 minus 4, that is 446 divided by 6. It gives us 74. And 74 times 6 plus 4 gives us 448. So we got 448. Similarly, in case of 5, we'll get 449, right? Now for 10, we'll get 6 values more. So what will it be? It will come out to be 454 and it is greater. So this will also come out to be 448 only, right? Now for 100, it is 450 minus 100 is 350 divided by 6, that is 58, and 58 times 6 plus 100 is, oh, sorry, 58 times 6 plus 100 is 448 again, right? So basically our values are, after sorting, 448, 448, 448, 449 and 450, right? Right. So our answer for this is what? 450 minus 448 is 2. Then we'll increase 448 to what? 454. So now our answer for this is what? 4. After this, right, answer will come out to be 4. Then we'll increase another 4 for it to 454. So our answer is again 4. Now for again another 4 for it to 454. Actually, sorry, this is not 4. This is 6 because 454 minus 448 is 6. This is also 6. Now when we'll increase this 448 to 454, our minimum is 449. So our answer come out to be 5. Now after increasing 449, we get 455. So our answer is again 5. And now after increasing 452, 456, our answer is 2, right? So our minimum answer is 2, right? And that is our output. It will come out to be same for this. There are only very less values, right? Or let's just do this also. We have 3, 9, and 21, and our k is what 10, right? So it 3 will come out to be 13, 9 is 19, and this is 21. So our current answer is what? 21 minus 13 is 8. After this, our 13 will change to what? 23. So our answer is 19 minus 23 is what? 4. Now 19 will change to 29. So our answer is now again 8. Now 21 will change to 31 and our answer is again what? 8, right? So our answer is basically 4 and that is our answer. So let's jump to the code now. So we first take the inputs, then sort the array. Then we do the operation we discussed, right? And sort the array again. Now our initial answer is our last value minus the first value. Then we increase our ith value and update the answer with ith and I plus 1th value, like taking the minimum of it and finally printing the answer. So, so yeah, D was also easy if you have done that code chef question, else you need to think it from scratch, right? But again, it was not, I hope you would have understood it, right? Else just check the code chef question now after this question and try to do it on your own. The logic is very similar. So the last question of today is Fibonacci strings. And you are given string x and string y, and we define as sequences of string s1, s2, and so on. Our first string is x, second string is y, and our subsequent ith string is basically the concatenation of the last two strings. And this is exactly the motivation of the problem Fibonacci strings because Fibonacci series is what? Fi is nothing but the sum of the last two values, that is Fi minus 1 plus Fi minus 2, right? And we need to answer Q queries, and each query we are given three inputs, that is L, R, and C. And we need to find the number of times the character C appears between L and R, right? And we need to do this in the S of 10 raised to 18th character, right? So for problem number E, we need to find number of times some character C appears in range L to R in string S10 to the power 18, right? So this is basically our problem. And we know our S1 is what? X, S2 is Y, right? So first of all, we are given 10 is to 5 queries, right? And basically, we need to find it in the 10 is to 18 string. So we can't really generate the string, right? Because we can't do a direct loop of, right? And in the first place, also, we can't write such a big string because even if the first two characters have only one character, right? And like in the first example, there is only one character for the first two strings, right? But still, the thing is that the Fibonacci series pretty much grows exponentially, right? So our number of characters will also grow very quickly, and our L and R is also between 118. But the thing is, our S of 10 is to 18 string would definitely have too many characters, right? It will have many characters, like a lot more than 118, right? Yeah, so what will be our S3? Our S3 is basically S2 plus X1, so can I write it as YX? Similarly, what is S4? S4 is S3 plus S2, so I can write it as YXY. Now S5 is S4 plus S3, so it is YXYYX. Similarly, what is S6? S6 is S5 plus S6, so it is YXYYX, and now again YXY, right? And our S7 is again concatenation of this, so it is YXY, YX, YXY, and again YXYYX, and so on, right? You can already see that the number of characters are growing too quickly, right? We had one character here, one here, we had two characters here, three in the next string, five, then number of characters are eight, and then it is what? 13 characters, right? Right. And obviously the length of SI is ith number of Fibonacci series, right? Because we can see our length is also increasing on this order only, right? And and the thing is Fibonacci series grows exponentially. We have already discussed it, right? But can we say another thing? What is SI? SI is basically SI minus 1 plus SI minus 2, right? So can we say that Si minus 1 is prefix of Si, and similarly Si minus 2 is prefix of Si minus 1, and so on, right? And we can see that we are only interested in characters from 1 to 118, right? Like L comma R can only go up to 118, right? So let's say our Si has some 10 raised to 100 characters, right? And let's say Si minus 1 has some. Now I'm writing some random numbers only here, right? Or let's just take variables. Let's say let's take another one, Si minus 2. Let's say Si minus 2 has X characters, this has Y characters, so this will definitely have Y plus X characters, right? And we can say first Y characters same as Si minus 1, right? And similarly for Si minus 1 also we can write first X characters same as Si minus 2, right? And we can write the same for Si as well, right? So let's say our ST has some K characters, right? So can we say that S 10 to the power 18 have first K characters same as ST, right? Can we say this? And we can actually notice it in the sequence as well, right? That S, like these eight characters, this is basically S6, right? And now if we see the first five characters, this is S5. If we see the first three characters, these represent S4. Similarly, the first two characters represent S3, right? And the first character represents S2, right? So we can see that this prefix properties always holds. So can we say that if ST has 10 raised to 18 characters, so first 10 raised to 18 of S10 raised to 18 are same as ST, right? And since our R can only go up to 10 raised to 18, right? So we can answer all queries from ST itself, right? So first of all, we don't need to find the S of 10 is to 18 string. We only need to find a string that has up to 10 is to 18 characters. And this is much easier than our previous problem, right? Because we know that since it is growing exponentially, so we'll get this string very quickly. And actually, if we just check the Fibonacci numbers, right? We'll get it somewhere, right? Or let's just take this GFG block and we'll just print the Fibonacci number, right? So yeah, let's just suppose let's print the 100th character, right? Okay, so let's just take the last code and print it here. The value is negative because it exceeded the range for the int. So let's change these values to long, long. Or actually, it is easier to just and we'll change this to actually what we can do is we can just copy this code and we'll run this here, right? Okay, the entire code is not even copied, right? And now what we'll do is we'll change all these to long long and change our main to int. And now let's print the 100th character. So we can say this is a pretty big number and if we count the number of digits. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So this is the 100 character is even greater than 10 is to 18, right? So we are only interested in some 100 strings, right? But now the thing is it is easier to generate 100 strings compared to 10 is to 18 strings. So we know that T is less than 100, right? So this does simplify the problem, but the issue is still we can't store, right? But we know one thing, right? We have some string st. We know that first k characters are from st minus 1, given that length of st minus 1 is k, right? So the thing is, if depending on our range of R, we can find the specific value, right? And does this go somewhere around recursion? Like we'll start with the stx string and we will keep going backwards to st minus 1 string, st minus 2 string and so on till we find the one we need, right? And we know that there are only 26 distinct possible values. So we can make a prefix count of these, right? To for all of these values, right? So let's understand how the recursion will work. Let's say that what exactly are we given? Right. We are given a range L to R. We need to find our question is frequency of some character C from L to R. Right. So this is equal to frequency of C from 1 to R minus frequency of C from 1 to L minus 1, right? And once we have formed some function to find the frequency from 1 to x, we can just calculate both of these values and subtract them. So now our main issue is how do we find frequency of C from 1 to x, right? This is our problem. So let's say that we are at the tx, let's say we are currently at our stx string and we know its length is, let's say k, right? And we need to find from 1 to x, right? So let's say that k is equal to x. Or first of all, let's just check all the conditions one by one, right? Let's our first two we know our first two strings are what? Our first string is x and our second string is y. Let's say its length is n1 and its length is n2, right? So now if x is less than equal to n1, right? So our answer is what? Like prefix count of we can say prefix count up to x for character C right? And if x is less than equal to n2, right, then it is prefix count of, actually this is not x, this is like the, okay, 1 minute. Let's write this again, right? So what exactly I'm saying is that our first n1 characters are from x, our next n2 characters are from y, and after this we have our third string, let's say s3, which has n1 plus n2 characters, right? And then we have our fourth string s4, which has what? 2 n1 plus n2 characters and so on, right? So if our x is less than n1, right? So basically what is our answer? We can get the prefix of this, let's say it is px, right, for prefix. Let's say for this we have px, for this we have py, right? We can find the prefix of at least these two, right? So this is basically px up to the xth value, and here we have what? N1, our character c, right? And if our x is less than equal to n2, right? Or can we say that our x is less than equal to n1 plus n2? Because our first n1 characters are different and the next n2 characters are different, right? Right. Suppose, actually we can't really do this directly from the length, right? We need some more parameters. These conditions are not relevant, right? What we know is that this string is S1 and this string is S2, right? So instead of doing the condition on length, let's say our t is basically, if our t is 1, so this is basically our x, right? So in this case, our string must be what? The first string, so it will be the prefix count up to the, what is the index? Again, our index is x, right? So up to x for the character c, and if our count is up to what? It is our second string, then our count is prefix up to x, prefix of y up to x this time, right? That is prefix of y up to character, like the index x for the character c. And now let's say our length, or like our, what is our length? Our length is x, right? If our x is equal to the length of our st, right? So basically our answer is what? Our answer is what? We can say that the count of characters in the th string for C, right? And else what is our answer? Basically, what is the else case? are the last cases that x is either less than, like we can say x is less than length of s of t, right? So we can decrease the string again. So our answer is nothing but answer for what? T minus 1, right? And our x will remain the same, right? And for character c. And if our x is actually greater than the length of st. In this case, we know that we'll get the whole count of this string plus what is the string after the t minus 1th string? It is the t minus second string, right? Because we know that st is basically st minus 1 plus st minus 2. So this whole string is coming and then this is also coming, right? And it is t minus 1, right? Because whole t minus 1 is coming and some part of t minus 2 will also come. And if x is less, so the whole t minus 1, some part of t minus 1 will come. If it is equal, whole string t is coming. And if it is our first or second string, then we are taking the prefix from that specific one, right? Now, calculating this is easy. Prefix for x and prefix for y, right? But how we'll calculate these two values? Length is also easy, right? Length of st is nothing but length of st minus 1 plus length of st minus 2, right? And how we'll calculate this count? Can't we say that count of t or st, if you want to include that, is basically count of st minus 1 plus count of st minus 2, right? And basically for each character c, because we can't add vectors directly, right? And this is basically for all c from 0 to 26, right? So we can get the count vector like this, the answer vector like this, and we know that length of 1 is n1, length of 2 is n2, and we also know that count of 1 is what? Px of n1 minus 1, and count of 2 is py of n1 minus 1, right? So with these information, can we easily determine what will it be? And this is basically recursion, right? So yeah, let's check the code. And the basic principle for this problem was identifying that we don't really need the 10 raised to 100 string. And the main point for it was because we are only interested in the prefix, right? Because the prefix is basically coming again and again, the same prefix, which we notice after writing a few terms, right? So since we know that the prefix is remaining the same, we don't really need the entire string, but we only need a string that covers the first 118 characters. And since Fibonacci grows exponentially, so we already know that we will get the first 118 characters before 100 characters, right? But the thing is, we still cannot store 118 characters. So what we'll do? Now we'll use the same principle again, and what we can do is that if we are onto our first two strings, then we can directly print the values from the prefix arrays which we have calculated. Else, if we are on the th string and th string has only that many characters like that we need, right? Th STH string has k characters and we need the count for some character from 1 to k index, right? So our th string will work. Otherwise, we need to decompose it. Now, if our x is less than the length of st, then we'll go to t minus 1. And if it is greater than st, then we'll include the whole string of t minus 1 and then we'll go to the t minus second string, right? Because st is nothing but st minus 1 plus st minus 2, right? So this was the basic idea for this problem, and let's discuss the code now. And I don't think there's much sense to discuss this first. So first of all, let's see the code. So basically, we are taking the input, then we are making the prefix count for px, like the x string and the y string, and it is basically copying the last vector and then increasing the current with the count of the specific character for both x and y. So this is making the prefix count vector for both of them. Then we are making a length string, and I've just done it up to 1,000 characters for safety, but we know we don't really need 1,000 characters and we can't even store that big of a value, right? And our first value for length is the size of x and the second value is size of y. For like total is basically the count, right? The count of that specific character for this string, right? The total count of this character for the specific string. So for the first string, it is the last value of the prefix count of x, and for the second is last value of prefix count of y. And now I'm like basically increasing and increasing the value of length by our formula and total by the same formula. And I'm doing this till the time my number of characters are less than infinity, and I've defined infinity as 118, right? Because we are interested in the count of strings up to 118, right? And now for a specific query, I'm just finding the answer for the value of r and the value of l minus 1, and just taking the difference of the two gives me the answer. Now, what is our function? If my current value, like the range value becomes negative for some reason, then I'll return 0 because it doesn't make sense, right? And my k basically tells me the t, right? So if it is my first string, then I just pick up the prefix count of the first string. Else I pick up the prefix count of the second string. Else if suppose I am on the kth string and my length of kth string is equal to r. So I like pick up the whole string. Else if it is less than or equal to it, again the equal to will not be triggered because it is already handled, right? So if it is less than it, right, then I'm returning that specific answer, and else I'm returning the answer for the previous value, like the k minus 1th value and the k minus second value, right? So yeah, this is basically a problem. Okay, and where were we? Right, now in this condition, my x cannot be greater than the length of st, right? Because it doesn't make sense because the length of the previous character will only decrease. So actually I wrote this wrong. This is actually what? This is actually st minus 1 and right, because if the length of x is less than the first half of the string, then we go into that part, right? And if it is greater than the first half, so we include the entire first half and then we go to the second half, right? So yeah, you can see that is basically the code. It matches whatever we have discussed, these conditions. And we are using the principle of Fibonacci series that first of all that the length, like our first principle is that the length is increasing exponentially, so we don't need a lot of strings. And the second principle is that since the prefix is preserved, So with the help of this prefix property, we are decomposing the strings and finding our answer. And basically we are counting accordingly, and it makes the problem simpler. And then we are finding the count of characters from 1 to r and 1 to n minus 1 and subtracting them, and that is giving us the final answer. So yeah, this is it for problem number E, Fibonacci strings. I hope you would have understood this question. It was a good question. And this is it for the AtCoder Beginner Contest 450.